Hello and welcome back to AlgoTutor sorting series. I am Akshat Jain and I am a software development engineer. In the previous lectures, I made you understand about the sorting series, sorting algorithms, which are bubble sort, selection sort, and insertion sorts. Today, I'm going to start with a new kind of sorting technique, which uses divide and conquer algorithm, and the name of the sorting is merge sort. So bubble sort, selection sort, and insertion sorts differs from the merge sort because in merge sort we use divide and conquer algorithm. I've been saying divide and conquer many times. So what basically divide and conquer is? Divide and conquer basically means we are going to divide our problem into various sub problems till it reaches a unit position, and after that we are going to solve that sub problem recursively. Now let's understand what is recursively and what is division of the sub problem. Suppose we are given an array 28539417. Now what we are going to do is, let me take out a pen. Now what we are going to do is we are going to divide the array into half till every element is not individual. Okay, so what is the half here? This is the half. So what will be our half? Will be now 2 8 5 3. Second half will be 9 4 1 and 7. Now again divide it into two halves. Okay, so here 2 8, here 5 3. Okay, now what will be here? 9 4, here 1 and 7. Okay, now again there is a scope for division, then do division. Now 2 8 5 3, the 9 4, here 1 and 7. Okay, now what we are going to do is, now since our problem has been divided into sub problems with a unit value, now we are going to merge them. Okay, now our task is to merge them. Now consider a temporary array. We are going to store our sorted elements in a temporary array. Now sort for these two first. So what will these two will give? These two will give 2 and 8. The temporary array is sorted. Now what these two will give? 5 and 3 will give? Obviously 3 and 5. Same goes for this also. 9 and 4 will give 4 9. Same for 1 and 7 will give 1 7. Now join these two arrays. So 2 8 and 3 5, what will they give? It will give 2 3 5 8. How it is been calculated, we are going to compare each values while merging them. So keep remember, while we are coding you have to implement that condition. The condition is we are going to check whether the element is greater or smaller, and depending on that position we are going to insert that particular element in that index. For this also I have an array 4917 which will give me 1479, and now we'll merge again. Since we are using recursion, we have to write a piece of code for single time and it will run for every operation similarly. Okay, now we 1 2 3 4 5 7 8 and 9. Okay, so I got the answer. So I hope the explanation is very clear to you. The time complexity would come out to be n log n. Okay, the time complexity would come out to be n log n because we are dividing our problem into half. How many times? N times. That's why. Okay, how many times? N time. 1 2 3 4 5 6. Okay, no, sorry, 1 2 3 4 5 6 7 8 times. N is what? N is 8. Okay, so this is how. Now let's understand the code first. Again, let's start with the driver program. I have taken an array 6 5 12 10 9 1. So we have passed what I have passed. See the parameters very carefully. I have passed the array. I have passed something as 0 and I have passed something as size -1. Okay, what is 0 and what is something? Let's look at the merge sort function. So dividing, we are going to divide the array. What is L? L is our left part and R is our right part. left part is what, 0, and right part is what, the last element. Okay, 0 and n minus 1. If L is less than R, basically means we are checking for a we are checking for a valid index. If L is less than R, obviously our left part should be less than the right part. Then only we can divide them. Then we'll create a middle point. I hope everyone knows how this is used to avoid the overflow of addition of integers and subtraction of integers, because if you are adding two integers, L plus R divided by 2, if L has its maximum integer range and R also has its maximum integer range, then it will give overflow. So we are writing this to avoid the overflow condition. It will give us the mid value. It is similar to mid is equals to L plus R by 2. Okay. If you know binary search, then you know this. Okay, no problem. Now what is merge sort? We are going to merge the array from low to mid. Low is the starting point to the mid, and second what? Mid plus 1. From the mid plus 1 to the right part. So what we are going to do is, we did this. First condition will be applicable for this part, and second condition will be applicable for that part. L to M, it is our M, so it will become what? M plus 1 to R. That's it. Now after we have divided them equally into a single part, what we are going to do is we are going to merge them. How we are going to merge them? We'll write a merge function with array L, M and R as the parameters. Now let's dive into the merge function, which is very important function, which has to be understood with very clear mind. So don't get distracted in the mid part. Now create L and M. We have to merge L and M into array. So we have to create two arrays. I have said that we have to create two temporary arrays while merging that. Okay. So we have seen I have created two temporary arrays first. These, then I merge these, then I merge this. Okay. So this is how you will do. Now Q minus P, it is P, Q, R is basically what? L, M and R. L, M and R. Okay. So P, Q and R is here. So int N1 is going to be Q minus P plus 1, and N2 will going to be R minus Q. Okay. So starting point of the left array and the second array. So L is the name of the first array, which is N1 length. M is the name of the second array with N2 length. I am going to put entire values first. Okay, I'm going to put entire value first. I have give the entire value first. Okay, now I have to maintain correct index of sub arrays and main array I, J and K. Now we are going to compare. Now while I is less than N1 and J is less than N2, I have to compare both the elements and put the correct element into its correct position. If M of J is greater, then I have to put at the kth index, I have to put L of I, because I have to put the smaller value, and I will increase I. Else I will put the M of J value and I increment J. After putting a value, I will increment K. Similarly, so understand this line very carefully. Until we reach either end of L or M, pick larger among elements L and M and place them in the correct position. Now, if we run out of L, okay, we are using AND condition here. What if this condition become false? We have run out of every ith element. N2 elements are still present there. So what we are going to do, when we run out of elements in either L or M, we pick up the remaining elements and put in the array A. So we are going to do this and do this for both of them. So this I will run this code and we'll see the output 1, 5, 6, 9, 10, 12. I hope you have understood the concept of merge sort very clearly. If not, I will recommend you to visit this video again. Try solving the try running the code by using a copy pen method. It will help you beneficially. So I hope this section of this algorithm divide and conquer is very clear to you. See you next in the quick sort video. Till then, bye bye.